When we were all on campus, you may have noticed some dude with a big green helmet and a weird electric longboard with big wheels, like what you see in this image here. Well, that guy is me. Hi, my name is Trent. I'm a mechanical engineer who loves building things for fun. My number one favorite thing that I've built for fun is my electric longboard. The longboard itself might be mistaken for something that I bought online or at the beta store in Santana Row, so many people don't even know that it was custom built. Even fewer people know what it looks like on the inside or how it works. Today, I'm going to uncover that mystery and show you exactly what's inside and how it all adds up to a home-built electric skateboard capable of moving up to 40 miles per hour safely. Here is a picture of the longboard. Nope, sorry, wait, not that one. This is a picture of the longboard. And to explain how it works, we can split the system up into 7 main parts. Let's open up the covers and go through each of these one by one. All of the electronics are housed in 2 main covers, which were 3D printed from ABS in the Maker Lab. Here's what they look like. I designed these to perfectly house each component. The battery pack is stored in the main cover. It's 2 22-volt lithium polymer battery packs, wired in series, so the whole thing runs on 44 volts. And the way they're wired, they can supply up to around 200 amps, meaning it can supply more than 8,000 watts. For comparison, most wall outlets supply less than 2,000 watts. These batteries are right underneath my feet, and they store a lot of energy. The battery can be very dangerous if handled incorrectly or punctured. Therefore, the battery is housed in a fireproof fabric, which is then separated from the 3D printed green inner housing shown here by shock-absorbing foam. The inner housing slips into the black outer cover, which is then bolted to the bottom of the board. Let's move on to the stuff inside the rear casing, which houses communications, the ESC, the powertrain, and lighting controls. The battery feeds power directly to the ESC via 8-gauge wires that go through the deck. The ESC, or speed controller, which is secured to the rear cover, converts commands like move forward to an electrical 3-phase signal for both of 2 brushless outrunner motors that drive the rear wheels via a powertrain consisting of Kevlar-infused 3D printed timing pulleys and Kevlar belts. I've gone through several iterations of these to make sure they hold up to wear, and they're incredibly reliable. They're also much cheaper than buying metal ones. Also, when dealing with motors, usually more voltage equals higher top speed, and more amperage means faster acceleration. I use the timing belt and the pulleys to gear down the top speed to 40 miles per hour, meaning it could go faster, but I'd rather have faster acceleration, and I don't need to go 40 miles per hour. Commands are communicated to the ESC via a paired remote and radio receiver, like an RC car. An Arduino-type microcontroller taps into the signal from the radio receiver and controls the brake lights appropriately. Then, last but not least, is the actual skateboard parts. These are the same as you would see in any longboard. If you want to learn more about that, there are plenty of resources out there to get started. So those are the basics, but of course there is so much more I could talk about, like the braking system, the battery charger, the headlights, motor mounts, you name it. If you like this type of content and want to know more, be sure to like and subscribe. Feel free to ask any questions in the comments down below. I really enjoyed this project, and I hope you liked learning about it as much as I enjoyed building it. And I hope you found it interesting to get a sneak peek into the mysterious insides of an electric longboard.